Right, this lecture might be a little bit long because it's just a whole bunch of examples, but you really need to know how to calculate these things. So work through these examples. Every time I'm about to give an answer, just pause. We'll make sure you can give the answer yourself and do it long after you think you've got it. Keep doing it and hammering it in, because understanding z-scores on kind of a gut level automatic basis is an extremely good goal. If you can do that, a lot of the rest of this class will be easy for you. So the learning objectives, we need to calculate these things. Calculate a z-score of any data point if somebody gives you the mean and standard deviation. To remind you about z-scores, they work with all distributions of numerical data, but we especially like them for normal data. We also can use the z-scores to compare things to each other, and we'll see how to do that. So BFL, brute force logic. Let's just go through the first few with pure BFL here. The definition of a z-score is the number of standard deviations any given value or a score is deviated from or away from the mean of its distribution. So it's just deviations expressed in numbers of standard deviations. So what's the deviation of this score from the mean? Well, how many standard deviations is that? That's all this is. If there's a plus, then that means that we've decided that that score is higher than the mean. If there's a minus, it's lower than the mean. So let's imagine that governors of states in the United States have a mean of 125, which is a ridiculously high mean IQ, and a standard deviation of 12, which is a little less than the overall population. Then find the z-scores for these following people. Governor Johnson, who has an IQ of 131, Governor Lincoln, 107, Governor Yalmas, 89. Now pause this before you go on, before you see the answers, but now I'm going to work through them. So you've got Governor Johnson, 131. Answer the question of what the z-score is for this person. How many standard deviations are there between 125 to 131? Exactly how many standard deviations? Well, the difference between those two numbers, 131 and 125, is just 6 IQ points. And the standard deviation is 12. 6 is just half of 12. So 131 is just half a standard deviation from 125, and it's higher than 125, so the z-score is 0.5. 1b we can figure out the same way. Governor Lincoln, IQ of 107, negative z-score because Governor Lincoln has an IQ below the mean of the group. So how many standard deviations from 125 to 107? So going down from the mean to Governor Lincoln's IQ, how many standard deviations? Well, there are 18 points, and there are 12 standard deviations, so that's 1 1/2 12s. 1 1/2 standard deviations. 1 1/2 standard deviations down is negative 1.5, because the score we're looking at has a value lower than the population mean. So 1C, Governor Yalmas has an IQ of 89. So how many standard deviations do we have to do? Remember that the standard deviation is the size of the step you take. How many steps of size 12 IQ points do we have to take before we get to 89 starting at 125? There's 36 points. This is not good. Governor Yalmas probably feels a little out of place when those people are all talking about Middle Eastern politics or calculus. So 3 standard deviations from 125, if you're going downward, will take you exactly to 89. So negative 3.0. You knew it, didn't you? There's a formula. Of course there's a formula. There's a formula for almost everything in this class. Sometimes it's not worth learning, but this one is. If you want to calculate the z-score of any raw score, so z of x, z sub x, if you want to know the z of any given x, then you take that x and subtract the mean from it and divide by the standard deviation. So you take the deviation of the x from the mean, and then you divide it by the standard deviation. In other words, you express the deviation as number of standard deviations. So x minus the mu, we do it that way instead of mu minus x, because if we did mu minus x, then we wouldn't have that lovely little experience of raw scores that are above the mean have a positive deviation, and those below the mean have a negative deviation. You can also use symbols for the standard deviation and the mean of the sample. It doesn't actually matter. Just once you get those values, however you got them, you just plug them into this equation: x minus the mean divided by the standard deviation. So in other words, it's the number of standard deviations away from the mean. So here's another formula that's useful. What if you solve that equation for x instead of for z? Well, then you get two equations that are what I would call a reverse z-score equation. I just kind of have that term. It doesn't sound very scientific. But this is where instead of being given a raw score, a mean, and a standard deviation, and asked to figure out what the z is of that raw score, you're given the z-score of a raw score and the mean and the standard deviation, and you're asked to find out what the raw score originally is. So same idea. You just plug those values in there, the mean and the standard deviation, and the z-score in this case. So let's say car miles per gallon. Mean is 27, standard deviation is 5. Find the z-scores of these 4 cars. Use just straight up logic and think it through, or use the formula, but you should try it formula at least a bit, because sometimes the numbers don't work out very nicely and you have to use it. So 2A, here's the answer for the SUV. How many standard deviations from 17 to 27, or counting downward from 27 to 17, which is actually what's happening here? 10 points, which is 2 standard deviations, because the standard deviation is 5. So 2 standard deviations below the mean, which means negative 2.0. Working that out with the formula, it's a little bit simpler on paper, but mathematically it's exactly the same as what we just did. Z of x is x minus mu over sigma. X minus the mean over the standard deviation. So 17 is x, it's the dividing point there, minus 27 over 5, negative 10 over 5. I think that's fairly obvious at this point. So 2B, a small pretentious hybrid, 42 miles per gallon. How many standard deviations from 42 to 27? There are 15 points, which is 3 standard deviations. 3 5s, 3 steps of 5, size 5 each. So 42 miles per gallon is actually 3 standard deviations from 27, and it's positive because it's higher than 27. So the hybrid z-score is plus 3. That's kind of a big z-score, just like the last one that was minus, right? So car miles per gallon here again. We've got the hybrid x minus mu over sigma, which gives us 15 over 5, 3. So the formula works out very nicely for this. Another example here, electric car, 82 miles per gallon. How many standard deviations from 82 to 27? So 27 up to 82 is another way to think of it. So if you subtract those, you find out that you have 55 actual miles per gallon units in between those. 55 is 11 standard deviations. It's 11 fives. So 82 miles per gallon has, my goodness, a z-score of 11, which is pretty ridiculous. So looking at this again, just plug in the formula, and you end up with the same answer. Final one, mom's van, 7 miles per gallon. There are 20 units or points from the mean down to x, which is what we're trying to figure something out about, to mom's actual van, 7. So 20 points, that's 4 standard deviations. 4 standard deviations is ridiculously far from the mean. That's an extremely unlikely point in most distributions. So 7 miles per gallon is 4 standard deviations. So mom's van's z-score in this distribution is negative 4. Is this making sense so far? Formulas, just applying that, makes everything slightly easier. But think through the logic if at all possible so you don't forget what that is. So let's say your friend Clark buys an intense SUV. The company's so proud of it that it says it's poorer gas mileage than 95% of all cars. So Clark uses some tools we haven't learned yet and figures out that this means it has a z-score of negative 1.65. How many miles per gallon does something get in this distribution of a mean of 27, standard deviation of 5, with a z-score of negative 1.65? I strongly recommend that you stop the video now and go figure this out. we have two formulas. One of them will work for this. If you can figure out what to plug in where, how to get the answer. So we use this reverse z-score formula because we know the z is 1.65. So what's the raw score that goes with that z? That's what we're trying to find out. Miles per gallon is the raw scores. So which one of those goes with negative 1.65? So we just take the z-score times the standard deviation plus the mean. Pretty easy, 18.75 miles per gallon, which actually isn't so terrible. So final exercise here, comparing two z-scores and seeing which one is the most extreme or least extreme within its distribution, even when you're in totally different distributions. And this is a way z-scores can be useful. So Rhonda gets 622 on the SAT verbal, and that score has a distribution, all the scores together, the population has a distribution of 500, a mean of 500, standard deviation of 100. Jennifer doesn't take the SAT, she takes the ACT verbal. And they're reading and finding out that these are really comparable tests. They're just scored on a different metric. So the ACT verbal has a mean of 21, standard deviation of 6. These are very different things. You can't just say, oh, Rhonda got a 622. She did way better than Jenny. Jenny only got a 27. No, because we have to take into account the scaling and variability of their own distributions. So Rhonda's z-score is 122 points away from 500. If the standard deviation is 100, then that's 1.22 standard deviations. So Rhonda's score is 1.22 standard deviations above the mean of her distribution. So z-score, 1.22. So the formula that we could apply to that is the same idea, 622 minus 500, which we just did, right? I mean, we did this just without a formula. And you divide there, and you end up with 1.22. Jennifer's z-score, she gets a 27, with a mean of 21, standard deviation of 6. How many standard deviations are there from 21 to 6? Or from 21 to 27? 6 points. That's exactly one standard deviation. So there we go. 27 has a z-score in this distribution of 1.0. So looking at that through the lens of a formula, you get the same answer. The z-score for Jennifer is her raw score minus the mean divided by the standard deviation. So her raw score is 27, the mean is 21, standard deviation is 6. If you put them in order, you make sure to get the right and the left and the positive and negative correct every time. So we get 1. So the question, which of them did better? Rhonda has a z-score of 122. Jennifer has 1.0. So Rhonda got a higher score compared to her peers than Jennifer did compared to her peers. So if the tests are fairly close to equivalent, then Rhonda is actually doing a little better in academic verbal skills. We'll pick up more with more practice next time. And until then, hasta la pasta.